In the last session, we have understand what exactly is ACF, and this ACF will exactly return me my Q value. So what exactly was ACF? So ACF was nothing but, let's say we have some data points, and this is exactly my correlation, which is in the form of this one, which is my x1 equals to some lambda into x2 plus some error. So whenever I have this equation, it means I have some correlation, and I have to deal with this correlation. I have to move this correlation in my time series data. So to remove this correlation, I have a visual, this one, and we have to understand this visual. And whenever I have my correlation value on the boundary, that value I have to select for my ACF plot, and that will exactly return me my Q value. So in this visual, my Q value is nothing but Q equals to 3. So this exactly is all the overview that what we have learned till now. So in this particular video, we are going to learn what exactly is PACF, which is my partial autocorrelation factor, which will give me my value of P parameter. So let me open a new page over here. So consider you have some data. Let's say I have some data over here. Let's say 100, 110, 120, and let's say 105. Let's say this is exactly my data set, and that correlation what we have studied in the last session, what exactly was this one. So this type of correlation we have already studied, and this is exactly my direct correlation, because you will observe over here the values are directly correlated to each other. But what if there is a chain in the correlation? So what type of chain? Let's say 100 is correlated with 110, and let's say 110 is correlated with 120, and 120 is correlated with 105. But what if this 100 will also correlated with this one? What if this 100 will also correlated with this one? And what if this 100 is also correlated with this one? So this type of correlation is nothing but my indirect correlation. This is my indirect correlation, or I can say this is my partial correlation. So this is a use case of your partial correlation, or I can say indirect correlation. It means 100 is affecting this 110, as well as 100 is also affecting this 120 as well as this 105 data point. It means each and every data is correlated with each other, and we need to minimize the effect of this type of partial correlation in this time series data. So what is the main goal of the PACF as well as ACF? The main goal of both the fancy terms is nothing but they have to minimize my correlation in data. So let's try to visualize your PACF graph. So this is exactly my partial autocorrelation graph, and you will see on y-axis you have some correlation, and on x-axis you have some lag, or I can say index. So on x-axis I have index, and on y-axis I have some correlation. So let's say my data was this one. Let's say 100, 110, 120, and 105. So this is my all the entire data that we are assuming for this particular video. So you will see over here, this is my correlation equals to 1. It means 100 with 100 has a correlation of 1. That what this line will tell. In a similar way, this one will tell, yeah, 100 with 110 have some correlation of somewhere close to 0.2. So this is exactly my correlation of 0.2. And now you will see over here at this index 2, you will see your correlation value is below the boundary. It means you can consider your P value as 2. That is a best way how you can choose your P value by using this PACF plot, and Q value using your ACF plot. Rather than considering some miscellaneous terminologies, this is the best way to compute your ARIMA model by using this PACF, ACF and differencing terminology. So our intuition behind ARIMA model is just about to finish in the upcoming session, because in the upcoming session we all are going to discuss what exactly is this I, which is nothing but my differencing. So in the next session we are going to learn what is our differencing in data, And behind this differencing, whatever fancy terminologies that are going to use in your time series data, we all are going to also deal with that. So that's all about this PACF plot. Hope so you will love this session. Thank you. Have a nice day. Keep learning, keep growing.